Hello, everyone. We'll be starting now. So we have a few folks joining us in person, and we also have a few folks joining us over the web. Okay, so I'm Sanket. I'm the CTO at BlobCity. We may still have a few people joining in late. It's been raining in Mumbai, and the ones you saw in the room in Mumbai. And so let's get started. Today we are going to make predictions on who is going to win the ICC Cricket World Cup 2019. So before we do that, let's look at some of the obvious AI and ML that happens today. We all know that we use various types of recommendation engines out there. We use predicting customer behavior. We use ad targeting in digital marketing for ad targeting, for AI generated content, including natural language processing. There are various use cases in which AI and ML is used today across a wide set of applications. And I believe all of us have come and basically experienced some of this AI and ML across various industry use cases. And this is very common, but what's not common is using AI and ML for predicting sports outcomes, and which is what we're going to do. The way we're going to show today is not necessarily the correct way, it's not necessarily the absolutely accurate way. The intention is to trigger some thoughts around the various ways in which AI and ML could be used for sporting events. So we may be wrong with our predictions, but we like to believe we are very accurate. We have done significant amount of back testing of our models across multiple matches, across series, and it has been accurate for more than 80% of the time. So we're going to show you how we bring about this level of accuracy in predicting sporting outcomes. So we have seen that today there are various business trends and benefits driving machine learning that we have. So companies are using some of this technologies for, say, demand forecasting, for also inventory planning. So if you have a store of your own and retail store and you want to do inventory planning in the stores, you do use a lot of AI and ML to basically predict what the sales will be like. And these models are getting better with time, and they are actually addressing a lot of business needs of customers today. So there are various stages to machine learning. This is at a high level for those of you who are new to machine learning in this phase. The main stages are you basically, this was published by Gartner in 2017. And they say to start with any machine learning problem, there are basically 6 primary targets. So you first classify the problem. So you take a problem that you have, and you need to first figure out whether machine learning is the right solution for this type of problem. Not everything will have machine learning as a right solution. So you need to identify if the problem you are addressing does have machine learning as a possible solution. Once you've classified the problem, you acquire data to do the machine learning, then you process data, then you model the problem, then you validate and execute your models, and then finally you deploy your model to a production environment wherein you would actually use this AI and ML to do any type of predictions or forecasting or anything that you wish to desire with the model. So let's get to the main feature of the presentation, which is predicting the ICC World Cup winners for 2019. Up until now, if there are any questions, please do feel free to ask. We are taking in questions from online attendees as well. So the ones joining in person, please feel free to ask directly. And the ones joining online, you will see a questions dialogue. So we will be answering the questions as and when they're asked. So if you have any questions, please type them in the dialogue. I won't be typing back a reply. I will actually be reading out the question and giving you a reply to the question you're asking. So moving on. So As until now, which is as until today morning, not until this minute, until today morning, in the current ICC World Cup, there were 15,912 balls that have been bowled so far. This takes into account extra balls that are bowled. So if a bowler bowls a wide and he repeats the ball because it was a wide, it counts it as 2 balls. And totally up until yesterday's match, end of yesterday's match, 15,912 balls have been bowled. We have taken data of this World Cup series. We have estimated the performance of each and every player in the current series. And we're using the performance so far in this season to predict the winners of the current season. So there's a specific reason why we did not take performance, historic performance of these players. So we initially considered historic performance across series, but the problem is we kind of observed that the team composition is extremely crucial to the predictives. So it's not just individual players, it's also the combination in which these players come together. And more so, different players have different levels of performance based on given weather scenarios, the cricket stadiums they're playing in, and also generally current level of fitness. So if we look at the historic performance of a player, say 1 year ago, and we look at the player today, the fitness levels of this player are significantly different. So the performance that they deliver is likely to be significantly different. So when we took data from historic matches and started predicting it, our predictions were not as accurate as they come out to be if we take only the current season, but which also creates a limitation that we cannot predict the winner at the start of the season, but maybe somewhere midway in the season, when each team has played about 2 or 3 matches, we are able to improve the accuracy of the prediction extremely high. So going forward, what we did is we basically computed, we basically split up the entire match into sets of 5-5 overs, which is the 1st to the 5th over, 6th to the 10th over, 11th to the 15th over, and all the way up to 46th to the 50th over. So once we did this, there's a reason we did this. So we're basically looking at how many runs were given by a bowler and when they were bowling in these sets of overs, how many extras were given, how many wickets were given, and how much was the total score that the team scored in each of these overs when against a specific bowler. So we're taking one bowler at a time and we're looking at how much was the scoring in each of these sets. So we label the sets from 1 to 10, which is all the way from set 1 to 5 all the way to 46 to 50, with 46 to 50 being set number 10. Now, there's a reason we did this is because if a bowler gives an extra run in the 46 to 50th over, we treat that as a very serious penalty. So towards the end of the match, you have to be very, very consistent in your bowling. Like in the last over, if you give a wide or a no ball, that basically counts highly negative against the bowler. So when we looked at the numbers, what we are saying is when there is an extra that the bowler gives, it counts as a negative. And if the bowler takes a wicket, it counts as a positive. So we took the wickets as an extremely good sign for these bowlers and extras as negative. And we adjusted all of these figures into the bowling economy of the bowler. So a wicket would improve the economy, and a wicket towards the end of the match would significantly improve the economy, while extras would decrease the economy of the bowler. But let's say if the bowler gave one wide in the last over of the match, they would basically be charged a penalty of 2 runs instead of a 1 run, which is a wide, because we treat that as a very serious problem. So we expect bowlers to be consistent towards the end of the match. Similarly, for the batting side, we computed, again, similar sets for batsmen's batting. It's reasonable to assume that the batting lineup remains consistent across a given series. So there'll be some batsmen who never play the 46 to 50th over, and there'll be some batsmen who only play the last few overs and never the first few. So, which is fine, and that is why basically the model kind of adjusts itself pretty much. So over here, we basically counted the runs they made in each of the sets, and we treat 4s any boundaries that they've hit as a strong positive and any sixes that they hit as a strong positive. But it's counted in such a manner that, so we basically computed the strike rate of each of the batting players. And if the player hits a boundary in the last over of the match or towards the end of the match, then if they score a 4-run, we would actually give them like 8 runs. And if they score 6 runs, we would give them like 12 runs. We would double the runs to count the strike rate. This is essential because when we consider a flat structure, we are not able to capture the general performance of the team towards the end of the match, because the last few overs are very, very crucial for both bowling and batting side. So how the teams are playing across these few overs greatly determines who the winner will be, because we have seen that a lot of matches are very, very close. They go down literally to the last over. Some matches you have significant margin. You might win against 60-run margin, 80-run margin. It does happen, and for those teams, it's not a problem. It's automatically going to surface out that one team is better than the other in terms of strike rate and bowling economy. But in other cases, what we've seen when the matches are close, a 6 and a 4, like a team that can hit a 6 and a 4 in the last over needs to count as a positive for the batting team, but it also needs to count a negative for the bowling team. And it's not the team, it's actually the individual batsman and the bowling team. So we computed this. Using this, we basically computed the strike rate of individual batsmen across the 10 sets that we have. And we also computed the economy of the bowlers across the 10 sets that we have. And as I mentioned before, we biased these events, in the final stages of the match. So if they took a wicket in the final stage of the match, it would be a positive, but if they gave an extra, it would be a negative. Similarly, a boundary towards the final stage of the match would be a positive. So that's what we did. Then we took all of this data and we set up a neural network. So I know this diagram does not look like a neural network, but I wanted to put it on a slide and make it extremely easy to understand. So the way this is done is, imagine the rightmost side is also actually on the left in a standard neural network diagram. So the left side is the batting input, the right side is the bowling input, but both are inputs. The right side is not the output here, the center is the output. So make a note of that in the diagram. That data goes in from both the left and the right side. And we set this neural network up, and there are hidden layers in between. So let me see if I can point this out to you. So, okay, so I'm not sure if you can see the spotlight. Okay, so what we did is basically we took the input from the batting, and the batting input comprises of, so we took all the 11 players, because we are assuming that if 11 bat, what would happen? So we're trying to compute that. So we took all of the 11 players on the batting side, and this is for a combination of teams. So we took team 1, which is playing against team 2, and the input was put as team 1, player 1, which is T1 P1 that you see at the top of the screen, strike rate. So basically strike rate of player 1 of team 1 minus strike rate of player 1 of team 2. So we basically subtracted strike rates across the best players. So we took all the 11 batsmen from each of the teams, ordered them in a descending order strike rate. So the highest strike rate player was kept on the top, then the 100, and the 100, and the 100. So the input at the highest point would be the player with the highest strike rate in that team, and the lowest point would be the player with the lowest strike rate in the team. And this is on the left side of the neural network right now. But we subtracted the strike rate of player 1 from team 1 minus the player 1 from team 2, and we took the difference as input for the batting side. Then we did a similar thing for the bowling side. We took the bowling economy of the players, and we took the player 1 economy in team 1 minus player 1 of team 2 economy, and we did the subtraction and we put it as input onto the bowling side. But on the bowling side, we only took 6 bowlers because sometimes, very rarely, a team could have a 7th bowler. But we're basically ignoring that. We're treating, kind of 6 bowlers as the primary strong bowlers. Most teams will have 5 as primary strong, but we counted an extra because sometimes there's a 6th bowler which is also strong. If there's a 7th bowler, we totally ignore it. So we take the best 6 bowlers that the 2 teams have from each of the teams, subtract the economy of team 1's best bowler minus the economy of team 2's best bowler, and put the difference as input into the neural network. So we did this. The output of the neural network is primarily it's a 1 and a 0 output. So the output is 1 if team 1 wins, and the output is 0 if team 2 wins. So if team 1 loses, it is 0. If team 1 wins, it is 1. So we took all the matches that are done so far, which is the 30, 33 odd matches which have happened so far. We've passed this data through the neural network, and we produced an output. We basically used the output based on the current known win and loss scenarios to actually train the neural network on, given a particular set of inputs, what are the odds of the team winning. So this neural network, because of the hidden layers, so you can actually see there are 2 hidden layers in between. So the input has 11 nodes on batting plus additional 6 nodes on bowling. So that's 11 plus 6 input nodes. The batting has additionally 3 nodes in between as hidden nodes, and 1 more after that. And the input for the bowling has 2 hidden nodes and then 1 more after that. And the 2 innermost nodes from the inner layer go to the 1 node, which is the output node. And this output node gives us the output of whether team 1 is winning or team 2 is winning. So we use this input as training data for the neural network. Then we take combinations of teams and feed them into the neural network to figure out whether someone is winning or losing. So we use the same neural network then to predict the winners of the tournament. So having done this, what are the results? So let's look at what our prediction says using this neural network. This is also a good time to start guessing on who you think will win the World Cup. So let's move on. And for training the neural network, I forgot to mention this, we used Hebbian learning with a simple feed-forward neural network. And the diagram you see is a feed-forward neural network with the Hebbian learning training algorithm to train the neural network, which is one of the simplest algorithms for training a neural network. It's also one of the oldest, and it closely mimics the way the human brain actually learns. So moving to the predictions, what we predict from today's match, which is today is June 27th, and match 34th is going on, wherein West Indies is playing India. Our neural network, and there is no human intervention in this, there is no bias whatsoever from my side or anyone from my team. This is directly output from the neural network that we programmed. And we will be publishing this chart as a tweet right after the session as a reference of what we have predicted. So we can go back when it's later, when these matches have happened, we can actually go back to this tweet and see whether our predictions were accurate. So we basically predict when West Indies plays India, India will win. When Sri Lanka plays South Africa, South Africa will win. Pakistan versus Afghanistan, Pakistan will win. New Zealand versus Australia, New Zealand will win. England versus India, England will win. It's not India here, England will win. That's what the model says, right? And when you go to Sri Lanka versus West Indies wins. Bangladesh versus India, India will win this time, Bangladesh will not win it. England versus New Zealand is England. Afghanistan versus West Indies is West Indies will win. Pakistan versus Bangladesh, Pakistan will win. Sri Lanka versus India, India will win. And Australia versus South Africa, Australia will win. There are, of course, variables in terms of the bonus points that each team may get based on their run rates and strike rates, etc. Those have been ignored for now. So what we did is we took the current points table that is there, and we gave 2 points for a win and 1 point, and 0 points for a loss. But in some cases, we used a few alternate models to actually predict. So in some cases, like this neural network works the best, but we use some other types of neural networks. So in some cases, we had counter predictions from the different models. So in cases where different models actually gave us counter predictions, we gave each team 1 point each. So we considered this as a draw to compute the final table of how the scorecard will look like after the 45th match is done. And our prediction of the scorecard basically says India will be at the highest point on the scorecard, and this ignores the extras. So if Australia gets a few extra points, it could go up to number 1. It ignores that. But considering our models and considering we did account for some of those extras, that extra points that you get, and based on that, India at a baseline level will be at number 1 position on the table with 16 points, Australia with 13 points, New Zealand with 13 points, and England with 11 points. So the prediction is on July 9th, Tuesday, in the first semifinals, India will play against England. And on July 11th, in the second semifinal, Australia will play New Zealand, because the first place the 4th position and the second place the 3rd position in the semifinals. So this is a prediction. We will be putting this out, so you can write to us later on whether we are right with the prediction or we are wrong with the prediction. So we like to believe we are right. Now, out of this, the question is, we again obviously use the model, we use some extra metrics to figure out when India plays England, who will win, whether it is India that wins or England that wins. And these are knockout matches, so there's no scores beyond July 9th. So whoever plays whoever wins goes to the finals between these 4 teams. So what we predicted for the finals, the teams that will play in the finals, amongst the 4 that come into the semifinals, is actually India versus Australia. So India will win against England, and Australia will win the other one. So India and Australia will go to the finals. Now, what happens after India and Australia goes to the finals, right? Is there any guess on who will win? Anyone joining us in person wants to guess who will win?
India.
India? What do you think? Is it because we are in India, or anyone thinks Australia will win? Australia. We have one person saying Australia will win. Anyone else saying Australia will win? We have 2 people saying Australia will win. Okay. So we turned out the numbers, and there is literally no bias here. It's all computer generated, right? We did not use any human discretion here. And the final output is India will actually win the World Cup again this year. And this is what we're predicting at this point in time. So let's wait and watch whether our predictions are accurate. And the idea here was mainly to give you an overview of how some of these predictions can be done, or how AI and ML can be used. It's crucial to decide what input data to take and what output to expect out of it. Like some models do take into account which team is playing first, who wins the toss, based on historic wins. If India plays Australia, then India wins or Australia wins. They're taking historic numbers. Those, in my opinion, are not actually very accurate, because we cannot treat India as a team. So the team India that is playing this year's World Cup is significantly different than the one playing last year's World Cup. So it's unreasonable to generalize and say that India always wins, say, against Pakistan in a World Cup match, which is true. It has happened, but it has literally happened. But it's unreasonable to use that data and extrapolate and say that India will always win Pakistan in the World Cup. That is not true. So because the fitness levels of the players, the performance of the players could be significantly different from year to year, and that's why we have taken into account the individual performances of the players. And by the way, when we ran the model for India versus Pakistan, the model did say that India will win against Pakistan, and which is exactly what happened. So this is a little bit about some of the predictions, right, for World Cup. We are putting these numbers out, so you can hold us accountable to the predictions we are making, and we would like you to do so. Now, before we close the session, a little bit about BlobCity. So BlobCity is a data analytics company. We are also the creators of the BlobCity database. So BlobCity database is a blazing fast, ACID compliant, NoSQL data lake. It supports 17 formats of data. It's fully SQL capable. It's DML capable, along with Java stored procedures for advanced data processing. So we are the sponsor of the database, and our source code is available on GitHub. The formats we accept are, you can throw in data like JSON documents, Excel documents, XML, web server logs, PDF, RTF. These are 17 formats if you wish to count them. So all of these data formats can go into BlobCity DB, which creates BlobCity as a data lake. And from there, you can supply this data to various analytical dashboards you want, or machine learning models, or even computer systems that are actually going to use this data from the data lake. So this analysis of the data for the World Cup that we did is all done using a product. We have folks capturing data of the match, ball by ball, noting it down, feeding it into the system. The system then churns out these numbers, feeds it into a machine learning model. The machine learning model is also run as a stored procedure inside the database. So the product is fully capable. We use the Java NeuRoF library, which is built into the product to do some of these machine learning-based neural networks, or NLP is supported, Scala mlib libraries are supported, so you could write a stored procedure in Java or Scala language. We are hosted at github.com/blobcity/db. We would like you to go and check out the product. We strongly encourage you to do so. If you're a developer yourself and an enthusiast about open source technologies, please do sign in to contribute into the database. We are actively looking to onboard contributors, and we will assist you with doing your first few tasks on the database to make sure you're comfortable with the product, and then you can start contributing. In my opinion, there's nothing better for a developer's profile than actually having the names on the contributors list on a database product, because database is the core most technology when any amount of data analytics or anything we do. There's literally no data science or analysis that happens without a good database in which this data is stored. This is a little bit about BlobCity. Our features include we're fully SQL compliant. It's designed for data lake. It's designed for update operations. So unlike Hadoop, when you load data into BlobCity, you can update and delete this data. We also support an in-memory storage engine for real-time analytics. 17 formats of data. We're fully ACID compliant down to individual data records. We support stored procedures. We have fine-grained access control. So you can actually decide, let's say you have an employees table with the salary for an employee, and you want to make sure your employees cannot view the salaries of other employees, but everything else in that table. You can actually configure a permission that says restrict the salary column in the table to specific users only, so other users won't be able to view that data. We're also available on the cloud, so if you would like to try us on the cloud, please go ahead and you can register from the website and try on the cloud. We also give add-on services like concierge onboarding. So if you're a large enterprise customer, you want assistance with onboarding this database, onboarding the data onto the database, we provide this to you. We offer hypercare support, which is a 24/7 dedicated email and phone support. If you also want engineers sitting in your office, we do provide that for use of the product. And we also give you query performance analysis, which means if you're firing queries on the database, which we think can be optimized for better performance, we will proactively come and tell you on how to change the query to get better performance without actually changing the results. So these services that are listed on these slides are basically commercial services. This is where we make money. The product is totally free and open source. There is no licensing limitation to the product. You can use it for as large a node as you want. It's horizontally scalable. We have customers who have put in several billions of data points on the database. They've used it on their own, and they've not needed any support contracts from us. So we encourage you to do that. Here are a few quick links. You can get us from the Docker store at the link specified. We will share a video of this presentation, so you will get access to these links. We're also available on the AWS Marketplace, and you can look at some of our technical documentation at docs.blobcity.com. We are a Gartner Cool vendor in 2016. We also graduated from the NetApp Accelerator in 2018. And we have CII Ahmedabad as one of the investors in BlobCity. So I'm also pleased to announce that on the upcoming Saturday, which is 29th of the month, we are doing a Hacker Saturday, which means we encourage developers to come join us in person, and we will give you. So this happens in Mumbai, and it happens in WeWork in Mumbai. So we will give you a space to code, free tea, coffee. We will also give you Wi-Fi connectivity, air conditioning, of course, and all the mentorship we can offer for you to start coding, start your open source journey. Anyone is free to come and join this. You're free to code on anything you like. There are a few rules though, and those rules include that you must be a coder. You must come in and code. This happens from 10 a.m. to 4 p.m. on a Saturday, and we're doing the first one on this Saturday. So you must be a coder. You want to code on something, and what you're coding on needs to be open source. It doesn't have to be the BlobCity database that you code on. You could code on any project of your choice, and we will help you with coding on that project. As long as it's open source, the venue is open. Venue and mentorship is all open for you to come and start coding. We will be giving out few swag, and we also arrange pizzas for lunch and cupcakes for dessert right after lunch. So do come and join in. We do charge a small fee. It's actually a gatekeeper fee, so it's a $5 fee. That's just to make sure we have only serious coders who are interested who come and join in. We take only 10 coders at a time, no more. So the 10 of you would basically get to network amongst each other and learn from each other. So the idea is just to do open-ended community building and help everyone start their open source journey. So that's a little bit about us, and I hope you've enjoyed the session. We will now open it for any question and answers that users may have.